Hi everyone. So today we are going to still be working on volume, but we're going to be finding the volume of composite figures. So that just basically means that we're going to be finding the volume of two figures that are put together into one. So go ahead and find your notebook and title it Volume of Composite Figures. Okay, so how we're going to find the volume of these composite figures is basically to find the volume of each separate piece of that figure and then add it together. So we're just going to go ahead and start with an example. So if you remember how to find volume, maybe a little note, length times width times height is how you find the volume. These are going to be rectangular prisms, so that's how you find the volume of a rectangular prism is length times width times height. So for example one, say we have something that looks like this. We're going to first draw our prism, a normal rectangular prism. But then off to the side of that, it has another piece over here. So you do your best to draw something like that. It doesn't have to look exactly like that, but make it look similar. Maybe even just draw a rectangle with a square beside it, just to get the idea of what we're doing here. All right, so now we're going to put some dimensions on this thing. So let's make the bottom all the way across will be 10. We'll make it 8 tall. We'll make this length 5, which makes this length have to be 5 too. I don't have to tell you that, because if that's 5 and this all the way across is 10, then the other half of this must be 5, or else it would not equal the 10 that's all the way across. So that one has to be 5. We'll make this little segment 3, which would make this side also 5, because all the way up and down is 8, so we have to have 5 plus 3. So sometimes you might not get all of the measurements and you're going to have to figure out what some of them are. So use the side lengths that you do know to figure out the ones that you might not be given. And then we'll just make it 1 deep. It goes back 1 is what we'll say. Okay, so that's a lot going on here. So let's figure out how we can break this down to solve it. Well, since we don't really know a formula for a shape like this, we're going to break this shape into shapes that we do know, and that would be rectangular prisms. So if we kind of cut this prism right here and break it into this prism and this prism, then we can think about finding the volume of each of those and then putting it together. So let's do that. So if we start with this larger one, we need to know the length, the width, and the height of this larger piece. So let's find the length of it. How far is it across? Well, don't just put 10 down, because 10 goes all the way across this whole thing. Remember, we cut it right there. So how do we know how far that is? If we look at the top side, it tells us how far it is. 5 all the way across. So that would be the length. So we're going to replace our L with 5. Now we're looking for the width. Width, how far back it goes. It goes back 1. I know that's way over here, but the whole thing goes back 1. So the width is 1. And then the height, we see right here, is 8 of our tall piece. So now we need to do 5 times 1 times 8. So that's 5 times 8. So the volume would equal 40 units cubed. This one right here. But we still need to find this volume so we can put those together. So this is the first half. Now we'll find the volume of the second part. So we need to find the length, the width, and the height of that section so that we can figure out its volume. So the length, again, up at 10, how long is it? It's 5 again. The width, how far it goes back, is still 1. And its height now is 5. Again, if you're not given that, you will have to figure it out based on this 3 and that 8. So if this is 8 all the way across and that is 3, then the rest has to be 5 so that it equals 8. So sometimes you might have to figure out some of this dimension. So it is 5, so that's 5 times 5, which is 25 units cubed. So that's what this section is. So now you will have to add those together, not multiply. If you think about it, we're not multiplying this volume by this volume, where there'd be 40 of these sections. We're just taking this one and adding it to that one. So if we do that, we're going to add 40 plus our 25, and together that equals 65 units cubed. That would be the volume of this whole composite figure. All right, we will do one more example because sometimes you might see it giving you the area of a certain base. So we're going to talk about that. All right, example 2, we'll make one that's longer maybe. So go ahead and draw yourself a rectangular prism, a little box. We're going to put a little piece on top of it this time. Okay. So we're going to say that we're going to draw a base down here. This base right here might get confusing. I'll leave that part out. This base right here, the bottom of this section, we're going to say B, capital B, equals, let's say, 24 units squared. That's interesting. So what that means is that the area of this base is 24 units squared. Okay? So if you remember yesterday, the capital B replaces length times width. So the capital B is length times width. So then your formula would be the capital B times the height. So now all we need to know is the height of this bigger section to figure out its volume. The area of the base is length times width. So maybe it's like 12 and 2. Because 12 times 2 would give us this area of 24. Okay? So if it tells you the capital B, then you just already are a step ahead because you've already done length times width. That's why it's squared, because it means you've already multiplied 2 of your dimensions, length times width. Okay, so then we'll say the height is 4 here of this part. This one will be 2 more tall, and we'll say that it's 5 across here. And then we'll say it goes back, the depth of it will be 2 also. Okay. So let's find the area of each of these sections. Let's start with the larger one that we're given. The area of the base is 24 and that the height is 4. So we're going to do volume equals capital B times H is what we're going to use because it gives us capital B. So volume then equals 24 times 4, the height. Okay, so 24 times 4 might be something we have to work out to the side. Maybe you do it in your head and you think, okay, 25 times 4 is 100. And I'm going to take 4 off of that. You can do it that way too. 4 times 4 is 16. Then you get 8 and 9, so you should get 96. So this area, this bottom one, is 96 units cubed. Okay, that's this piece. We still need to find the volume of this piece to add to it. All right, so that one we don't know the area of its base, so we can use volume equals length times width times height to figure out that one. So the length of that piece up there, this piece, is 5. The width, how far it goes back, would be our 2. And the height of that piece would also be 2. So we got 5 times 2, which is 10, and 10 times 2, which is 20. So the volume would be 20 units cubed. So that's this section. So now we're going to add our 96 and our 20 together to get the volume of the whole thing. So 96 plus 20. We're going to add those up. And you get 116. So the whole thing is 116 units cubed. Okay, you have, I think, about 5 problems on a slideshow to do. Make sure you do each one carefully. One of them does give you this capital B, the area of the base. So make sure you can also use this formula, volume equals the area of the base times the height, which is really just length times width times height.